YouTube, but I'll put the link online. What I'm going to go over is homework 3, which is all vectors. And if you have any questions, please stop me. And otherwise, I'm just going to roll through. So our first question, what we're going to do on this one is we're given a vector E, and we're shown 2 angles, an angle from Y and an angle from the X, which is a phi, and this is a theta. So what they want is we want to figure out what are the X and Y components of this vector. So the first question they ask you is to give the symbolic EX and EY for this guy. Now, if we look at this vector, remember that on a right triangle with a hypotenuse H, the X part of H, the Y part of this would be the hypotenuse times sine, and the X would be the hypotenuse times cosine. Now, the vector we're given, however, and the angle we're given are down. So you have to kind of imagine that this is a right triangle that looks like this, where this is our E and this is our angle. So if you turn it, E to the X is actually going to be E sine of theta, and E to the Y is going to be down. So this one will go that way, and this one will be E to the Y, which will be negative E cosine. So hopefully that makes sense to everybody. If you look at this, E to the X is going to go from here to here. You could actually move it up along the x-axis, but it's E sine because it's the opposite of the angle. And then E to the Y is going to be down, so it's going to be E cosine. And as I said, just go ahead and pop in the chat if you want me to stop and explain anything. The negative sign is because we're going down. And then it's going to ask you for using the phi angle for EX. EX here would be along the x-axis. It'll be E cosine of phi, and E to the Y will be down, and it'll be negative E sine of phi, which is, as you see, negative. So this one's really about just making sure that you can pick out the X and Y components of this vector. I think that's pretty easy for everyone. I hope it is. And we'll move on to things that are a little harder. So now we're given 2 vectors, C and D. And the thing you need to remember is there are multiple ways to write a vector. We can write a vector, let's say a vector A. We could write this vector as its X components and its Y components and its Z and however many else. We could write it as a magnitude at some angle to some axis, which is what they've done here. So what we need to do is we need to find the X and Y components of vector C. Vector C, on mine at least, your numbers may be different, is it says that it's 2.45 meters, 15 degrees above the negative x-axis. So when we draw our axis, remember that this is our positive y, and this is our negative y, and this is our positive x, and this is our negative x. And they're saying this vector points 15 degrees above the negative x-axis. But when we write Cx and Cy, what we are going to need to do, so C is given as magnitude at some angle. Magnitude of C times and cosine of this angle is our cx. And magnitude of c times sine of this angle is cy. However, our angle has to come from the x-axis. So from here to here is 180 degrees, which means this is 180 minus 15 degrees. And that would be 165. So this will be, C is, for me, 2.45. 2.45 cosine of 165 and 2.45 sine of 165. Now you could actually write this as negative 2.45 cosine of 15. That would still give you the right answer. And 2.45 sine of 15. And that's because sine of this and sine all the way across are the same. And cosine is negative on the other side. But regardless, if we want numbers, oh, and I should actually, never mind. 2.45 cosine of 165 is negative 2.3666. So negative 2.37. And you might want to put a little x hat just to remind yourself it's in the x direction. 2.45 sine of 165 is 0.64 or 34. And you may want to put a little y hat, just to remind yourself it's in the y direction. So negative 2.37, 0.634, which is what we got. Similarly, similarly, they're going to ask us, and you can see here that this is what our vector would look like. Similarly, they're going to ask us for D. However, D is easier because it's 30 degrees to the, well, I guess it's not easier, 30 degrees to the right of the negative y. So for D, remember this is the positive y, this is the positive x, this is the negative x, and this is the negative y. And they said 30 degrees to the right of the negative x-axis, which is something like this. Now, you can write this angle as either coming from here all the way around, it would be 90, 180, 270 plus 30. So this would be 300 degrees, or negative 60 degrees, whichever way you want to write it. It should give you the same answer. D for me is 31.6 meters. So I will write dx is 31.6 cosine of the angle, and dy is 31.6 sine of the angle. Obviously, this is x hat, this is y hat. And 31.6 cosine of, let's go, negative 60 is 15.8 in the x hat. And 31.6 sine of 300 is negative 27.4. Your numbers are different, I think. So we see that D is here. They did just 2 sig figs because the angle was 2, I believe. So 16 and 20, negative 27. The negative sign is important. The y direction, it goes to negative. The x direction is positive. Hopefully that makes sense to everybody. This is really just to give you some practice on finding the components of vectors. It's really important to be able to decompose vectors into their components. All right. Now we're actually going to use these. And this is a little bit about determining resultant vectors. So Ruth is setting out for her friend Ward's house, and he lives 20 miles north and 100 miles east. So let's just do this really fast. Starting from the origin, east is along the positive x, west is always negative x, south is negative y, and north is positive y. Says that her friend Ward lives 20 miles north and 100 miles east. So that's somewhere like here, 20 and 100. Now, she starts driving east, but after 70 miles, she comes to a detour that takes her south. So what I'm going to do is I'm going to make a vector A. And A is 70 miles east. But that means it's in the x-hat direction, in the positive x-hat direction. This is positive y, and this is the negative y. And this is the negative x. So the vector A, her first step of her journey is 70 miles east, which is 70 miles in the x-hat direction, and 0 in the y. Then the detour takes her 15 miles south before going east again. So this will be B, and B will be 15 miles south, which is 15 miles in the negative y direction. So negative 15 miles in the y direction. And then she drives east for 8 miles and runs out of gas. So then she goes east again for 8 miles. And she runs out of gas. And then Ward wants to fly from his house to where she's at. And we're going to call that vector D. He's going to fly from where he is to her house. Now, in order to find Ward's displacement vector, we need to do something, a little added part that may not seem necessary, but it actually makes it easier, I think. So let's call this R. And remember when we walk vectors, we're going to walk along her path. We get A, because we're going along A, plus B, plus C, minus D, because we're going backwards to Ward's house, minus R. Okay. Now, this is equal to 0. And we want to find D. Remember, this is actually not an equation, it's a relationship. If we solve this for D by moving D over, or adding D to both sides, we get D is A plus B plus C minus R. Well, R, we were told, was 20 in the X, or 20 east, and 100 in the Y. In order to find D, we have to add all these up. These become negative because R is negative. And we can just add all these up, and that'll give us the components of D. Okay. X is 70 plus 8 minus 20. 78 minus 20 is 58. In the X, minus 15 minus 100 is minus 115 in the Y. Okay, and hopefully that makes sense to everybody. All we did was we followed her path. We then drew the vector from Ward's house to her plane, and then we drew an R vector to Ward's house. And that allowed us to turn this into a very simple math problem. What did I do wrong there? I had that super wrong. So hold on. 20 miles north. Oh, I flipped those. I am so sorry. Whoops. Sorry, guys. You can always yell at me. This was 20 miles north and 100 miles east. These are flipped. Check these. So 78 minus 100 is minus 22. And actually, I've drawn this. It should look something more like this, I guess. It's like somewhere here. It's 20 and 100. So that R goes like that, and D goes like that. It's not super important, but so that's minus 22, and then this is minus 35. Sorry, I flipped X and Y in my head when I wrote them, which is what they got. All right, now we want to know the magnitude of Ward's displacement vector. The magnitude of any vector is its components squared and summed together. So you take the x component and you take the y component and square them. For Ward's, which we call d, this will be dx plus dy squared, which will be negative 22. You don't need to worry about the 22, or the negative, I mean, because it's squared. So I get 22 times 22 plus 35 times 35. Don't forget to take the square root. I get 41.3 or 41 miles. So the magnitude, how far he had to go in a straight line, was 41 miles. Then we want to find the angle measured from the negative y-axis. I think it's actually easier to find it from the negative x-axis, and then we'll figure it out from there. They want it from the negative x-axis, but we know that his vector looks something like this, okay? We go back and we look at D. We can pick D up and move it to like here. You can always move a vector around anywhere you want. You just can't change its magnitude or its direction. So we know it's going to be in quadrant 3 because negative x and negative y in quadrant 3, 1, 2, 3, 4 of the quadrants. How we find that angle is arctan of dy over dx, okay? And so that is arctan of negative 35 over negative 22. Now your calculator is not smart. It's going to give you probably a positive angle because it doesn't realize there are negatives. So arctan of negative 33 over negative 25, I get 52.8, which is somewhere here. But that angle can't be correct. We know it can't be correct. So we need to add 180 to flip it. Let's add 180 to it. So the angle from the x-axis is 232.9 degrees. However, they want the angle from the negative y, which is weird. I know, it's a little weird. Measured clockwise from the negative x-axis. Well, y is along 270. So let's take 270 and subtract our angle. And we get 37.14. So this is 37.14 degrees. And that's actually the angle they're asking us for. If they only want 2 sig figs, it's 37 degrees. They're saying it's 32 degrees. Did I flip my sign somehow? Sorry, arctan of, oh yeah, I did. I know what I did. Sorry, guys. Plus 180. Yeah, I'm dumb. I put 33 instead of 35 when I figured the angle. The correct angle is 32 degrees. I wrote 35 in it, or 33, and it should have been 35 and 22, right? Because I'm crazy. It's been a long day. Yep. So I wrote this wrong, and when you do that correctly, you'll get 32 degrees. 35 and 22, which gave me 237.8. And then when I subtract those, I get 32. All right, 57.8. Anyway, so this problem's a little weird, and it's actually a longer problem than you would probably expect. There are probably other ways to figure this out. Essentially, you could find what was her final X point. So she went 70 miles east, and then she went another 8 miles east, and 15 south. So she went 78 in the X and negative 15 in the Y. And that was, this is her. So I don't know what her name is, her. And then Ward came from 100 in the X and 20 in the Y. And then what you could do is Ward flew, so Ward to her position. And you could say that R is her position minus Ward, which would be 78 minus 100 in the X hat, plus minus 15 minus 30 in the Y hat. And that would have given us the same vector for R. It would have been minus 22 in the X, minus 30, sorry, this is 20, minus 35 in the Y, which is actually probably an easier way to do it. But at that point, to find the magnitude, you would take Rx squared plus Ry squared. And then to find the angle from the X, you would use arctan. But there's a little wrinkle here, and that's that they want it from this angle. And in order to find that angle, you're going to get this angle from doing arctan. If you put it in your calculator, it's actually going to give you this angle. So add 180 and then subtract that angle from 270. So this is 270 minus whatever this angle is here. And the angle they're asking for is 270 minus 7. It's a mess. So mastering physics being difficult, but hopefully this will help you understand vectors and how to figure out where you are. All right. The next step that we're going to do is about turning our axes. So in this problem, we have a pine tree that's growing on a slope that's 30 degrees. And the pine tree, we're assuming, is growing like this. I could make it look more like a pine tree, but whatever. And a pine cone is going to fall and hit the ground, okay? Now, what is the component of the pine cone's impact velocity parallel to the ground? So when we turn this thing so that it looks like the tree growing straight up, and the velocity is actually going to be like that. What we're going to need to do is find the velocity this way and the velocity this way. Now, in order to do that, we have to draw this. This angle is 30 degrees. That means the velocity when it hits the ground times cosine of our angle, 30 degrees. And this right here, let me draw it a little bit better. So we have, this is the angle of the final velocity of the pine cone before it hits the ground. That angle has to be 30 degrees. Why? Because our slope, this has to be a right angle. In order for this to be a right angle, then this is going to be 30 minus 90 minus 30, and this will also be 30, so this will be 60. But this is actually how our pine cone falls. Our pine cone falls along that same line. Therefore, if we decompose this vector, we get b final cosine of 30 with a negative sign, and b final sine of 30. It's important. When we have to do things on inclined planes later, we need to be able to break it up. So it hits the ground at a speed of 15 meters per second. 15 sine of 30 is, sine of 30 is 1/2. So this would be 7.5 meters per second. 15 cosine of 30 is 13, but it's negative. So the x, or the parallel to the slope, is going to be 7.5, and perpendicular is going to be negative 13. Hopefully that makes sense to you. Again, just to look at this angle. If we draw this, and I know that angle is exaggerated, but we draw our pine cone. Well, let's draw our, let me actually take that back for a second. I'm gonna make the tree look a little higher. It's going to fall straight down. So notice, if I cut this, this is a right triangle. So when I turn this on its side, okay, the angle that the pine cone is going to hit is going to make a right angle. If I draw a perpendicular line and I draw a parallel line to the cliff or to the incline, this is phi. These two angles add up to 90, but these two angles also add up to 90. So this is the same 30 degrees. The parallel part of our B final vector is down the slope, the B final sine of our angle, and we're assuming that's positive. This is down the slope, B final cosine theta. It's just the cosine, the x part of this angle, and the y part of this angle. Hopefully that makes sense to everybody. All right, more than halfway done. All right, so now this one shows 3 different forces. When we add forces together, unlike vectors, we draw all the forces at the same point. So all of their tails are together. We break them up into their components, and then we add all the x's and we add all the y's. But we have to choose a positive and a negative x and y direction. They've done that for us. So x will be positive that way, and y will be positive up. Now, we know that this one is in the x direction. So this, I'm going to call this vector A. A is 3x half. And if you just look at it, it's there. Vector B is 5 at 120 degrees. Okay, let me just draw it as a ghost. And this is 120. So BX is B cosine of the angle, and BY is B sine of the angle. Further, we know it's 5 and 120. And 5 and 120. And so 5 cosine of 120 is negative 2.5. And 5 sine of 120 is 4.23. And then finally we have, so we have dy and dx. Finally, we have this third one that we don't know the angle, and we don't know the components. So how are we supposed to find them? Well, she says that we show 3 ropes tied together. One of your friends pulls with 3, another pulls with 5. How hard must you pull to keep the knot from moving? So our CY and our CX should point this way. Okay, the magnitude of C at whatever angle it will be, the magnitude of C is going to be the square root of the components. How are we going to find those components? Well, this has to be such that they all add up to 0. And this has to be such that they all add up to 0. So C needs to equal minus A plus B for each of these. Whatever these add up to, C has to be a minus. So 3 minus 2.5 is minus 0.5. So 3 minus 2.5 is 0.5, and C needs to be minus 0.5. Hopefully that makes sense to you. C has to balance everything in the X, and C has to balance everything in the Y, which is a little bit easier because we only have one component in the Y. So now we have C, X, and CY. Magnitude, how hard you would pull, is just 0.5 squared plus 4.33 squared. 0.5 times 0.5 plus 4.33 times 4.33. Square root of that answer is 4.4, let's call it. A week from tomorrow. So 4.4 newtons. Exam is a week from tomorrow. 4.4 newtons using 2. Now, what is the angle? What direction must you pull to keep it? Okay, so the angle of C is arctan of CY over CX. Arctan of 4.33 over 0.5 is 83.4, but that's here. So we need to either subtract or add 180 degrees to 83.4. I think you're gonna take it as negative, so subtract 180, and that's 96.5, so minus 97. Why? I believe that's wrong. Let me double check myself though. Arctan of, I probably did something wrong. 4.33 divided by 0.5. It's 83.4. Yeah, I'm just sure I'm probably wrong. So this should be, yeah, I think they're messed up actually. Let me redraw this. So if RC has 4.33 in the negative direction and negative 0.5 in the X direction, it should look something like this. This would be 83.4 below the X-axis, which is, if I add 180 to it, would be at 263.4. 83 degrees below the negative X-axis. So I don't know why they're taking it from below the negative X-axis, but it would be 83.4 below the X-axis. When you look at this triangle, okay, this triangle here and this triangle here. So this and versus this, okay. This triangle is 0.5 and 4.33. So this angle would be 83.4 degrees. Because this is arctan of 4.33 over 0.5. If you were to do this, you would get 0.5 and 4.33. And so you get arctan of 0.5 over 4.33. But because they want this angle, you would say 90 degrees minus that angle. Anyway, I don't know where they said to take it from the negative axis, but for this one, you just find whatever vector will make these two 0, and then figure out from its components where it is already. I think that was pretty simple. This one is kind of the same. The forces are shown. F1 and F2 are given. In fact, F2 is given as 20 degrees. Let's make the components of F2 really fast. F2x and F2y is F2 cosine of the angle and F2 sine. This is X positive, this is Y positive, so these will both be positive. 6 cosine of 20, 6 sine of 20. That's 5.64 in the X hat and 2.05 in the. All right, so we know what F2x is, F2y is, we know what F1 is, We don't know F3 and we don't know F4. What is F3? Now, we redraw these. We have F3 points up, F4 points down. Sorry, F1 points down. F1 is negative, well, don't write negative, is 5. We don't know what F3 is. F2 in the X points that way, and F2 in the Y points that way, and F2 in the Y was 2.05. And then we have F4. Now, in the X direction, I'm sorry, in the Y direction. In the Y direction, we have F2Y plus F3. These two vectors are positive because they point up. F1 is negative because it points down, and we're assuming that this thing will not move. So we get a 0. So F1 is negative because it points down. F2Y and F3 are positive because they point up. We want to find F3. Add F1 to both sides, subtract F2Y to both sides, and we get 5 newtons minus 2.05 newtons. That is 2.95 newtons. F4 is the opposite of F2. So F2x minus F4. Note, F2x is in the positive direction, F4 is in the negative, so it gets a negative sign. That's equal to 0. F4, add to both sides, and you get F4 is equal to F2x, which is 5.64 x hat. Yep. That is the magnitude, by the way. F4 does point in the negative direction. So 2.9 was F3. It's only in the X direction. I don't know why they rounded it, I guess, and I didn't. So they rounded it up to 2.9. 2.9 newtons and negative 1.6. What did I do? Did I do that wrong? 6 cosine of 20. I believe that's wrong. F4 should be 6 cosine of 20 with a negative sign. Why are they getting negative 1.64? 1.64 divided by cosine of 20. Yeah, this is wrong. Where I'm dumb. Looking here, F4 points that way. It should be equal to, unless I'm missing something. So the net force, oh, I'm done. Sorry, you guys, I'm done. Let's back up for a second. So there is a net force, F net. I need to, I'll just do this so I can, no, I don't want the design. That's my stupid. All right, anyway, I'll write it here. I don't know what's going on. So our F net is equal to 4 in the I hat or X hat. I and X are the same thing. 4.0 in the X hat plus 0 in the Y hat. Now, when we go back to this is okay because our F net in the Y was 0, and these were all the forces in the Y. However, when I go to this one, in the F net in the X is equal to F 2X minus F4. So F2x, if I go here, was 5.64. This is 4. This is 5.64 minus F4. Now that looks like a y. So F4 should equal 5.64 minus 4. Subtract 4 from both sides, add F4, which is 1.64, which is why I messed that up. I'm sorry, which is 1.6. It's in the negative direction. 2x is 4. Need to be 4. I don't know why it's not giving me a negative sign. Oh, because I'm dumb. This is plus F4. So this would be, yeah, negative, or F4 is equal to 4 minus 5.64. I'm being bad on my signs, and I'm sorry. And the x hat, which is negative 1.64. It's been a little bit, sorry. All right, our final bit is back to figuring out parts of forces. And if you look, Cami is walking through an airport with a 2-wheeled suitcase, and it's tilted at 44 degrees from the vertical. And she's pulling parallel with a force of 100 newtons. What is the magnitude of the horizontal component of the applied force? So if you imagine you've got this suitcase and you're pulling it at 44 degrees with a 120 Newton force, okay? We want to find the X component of this force, and we want to find the Y component of this force. This angle is 90 minus 44, or 46 degrees. So F of X is 46 degrees, is 120 newtons at 46 degrees. Fy is 120 newtons at 46 degrees, but this would be the cosine part, and this will be the sine part. So F of X is 120 cosine of 46. F of Y is 120 sine of 46. Incidentally, we could actually write 120 sine of 44, which would be this angle, and it would be that part. And we could write 120 cosine of 44. They will give us the same answer. That's because sine and cosine are off of each other by 90 degrees. You can try it yourself, but 120 cosine of 46 is 83 and newtons, and 120 sine of 46 is 86 newtons. If I do 120 sine of 44, I get 83. 120 cosine of 44, I get 86. So 83 and 86 newtons. 83, 86, and that's it. That's all the homework. When you do homework 4, there's a couple problems that are a little hard that I'll go over in class tomorrow, or I'll cover them during review. I'm going to post the solution to the practice exam tomorrow after class. So look for that then. But I urge you to try it before on your own. We'll talk more about projectile motion tomorrow and a couple other little things. But yeah, other than that, have a good night. I'm done. If you have any questions, let me know now. Otherwise, I'll see you all later. Thank you all for coming. Guys. Bye, everybody. Have a good night. Be safe.